We are now to discuss another application of logarithmic function. Here it is called the logarithmic transformation. In many scientific research, some scientists want to find out the relation of two variables like the x and y here. They will get some data from the experiments. Let x equal to 1, 2, and 3, 4, then their corresponding y value will be find out is 2, 4, 8, and 16. Then you want to find what is the y in terms of x. If you're looking at this one, someone will be predict this one will be y equal to 2 to the power x. It is the exponential time. And here you will find when you're putting x equal to 1, 2, 3, and 4, you will get 2, 4, 8, and 16. So if you predict your model, then you can get the values of prediction when x equal to 5. Putting here, you will get 2 to the power 5, then the y is 32. But this one is very simple when you're looking at here example. But why we get 2? How can we get? You are not given in the experiment, so you may try to find out what number you want to put here. So if you want to find this one, then you will want to do something which is not just a try and error. We can get something called the transformation by using logarithmic. If you look here, this one y equal to 2 to the power x is just a simple one, but actually the exponential function with x in the power is just equal to y equal to k a to the power x. And here is the expressions. But you must sure that k and a must be positive, because if I want to take logarithm, the right hand side must be positive. And also a cannot be 1. Similarly, another function which is called the power function, just like you learn about quadratic, y equal to x squared is the simplest one. You find that fx just like the x and k is just the 1 and n is equal to 2, so it's y equal to x squared. But actually we do not know what is the k and what is the n. And also the fx I will expect will be a complicated function, just maybe x plus 1 or x plus 2, not only just x. So in order to make this one clear, I want to make sure you want to do something calculation by taking logarithm. Also may have the properties that k and the fx must be positive and fx cannot be 1. It is the condition that you must first want to take. If you have an exponential graph like this, you will find a graph like this. The x-axis and the y-axis. Then you will get. But this graph is just for a greater than 1. If you have a less than 1, then you will have another graph in this direction, okay? But both of them are very difficult to plot, because when you're putting the point just like this one, 1, 2, 2, 4, 3, 8, and 4, 6, 16 on the graph paper, and then you connect them by a graph by hand free, it is very difficult. So we try to use a graph paper also, but may change the y-axis and the x-axis with a different symbol. Now let's show you the first model about the exponential time. Y equal to k a to the power x. K and a both are positive, and a must be not equal to 1. By taking logarithm on both sides, which log you will want to take, because natural log is more common, so we always using this one. But you can also using the common log, log. Because your calculator also provide this common log. If you're taking the natural log on both sides, the expression k and a to the power x is a product, so you can using the properties of the logarithm, it will break down into two terms added together, and log k plus log a to the power x. But you have further properties that log a to the power x and the x can be go down to form this one. Many students like to say x log a plus log k. It's okay, but if you want to make clear, you can make the log a in front of the x. Why we get this one? You can see on the left hand side it is not y, it's not a y. So we use a symbol called capital Y to represent this log y. And then this one, it is log a. And we have another symbol. We use a capital X. And finally, we have a plus log k. This one is just like y equal to mx plus c. You learned it in the mathematics. It is a straight line equation. So originally, y equal to kx to the power is a curve. But now when you're taking log on both sides, with the y-axis is log y, and the x-axis is still x, so you take x here, and you can plot the graph with the x-coordinate is x, but the y-coordinate is log y. Then you will plot some point, and then connect them with a straight line. And this straight line you can extend to a supertotal length to pass through the y-axis to get a y-intercept here. And also the slope you can calculate by taking any 2 points on the straight line to find out the answer. So this expressions is the things that you want to do. In many questions, you want to do the transformation first. After you make the transformation, you must show that what is the value pasted in the vertical axis and what is the value is pasted for the horizontal axis. Let's show you an example, and this one should also show you that you can take log. Why we have this one? Because we have 2 buttons in your calculation, so we can do it like this. But actually, the question will tell you which logarithm you want to take. In this example, 2 variables x and y connected by the relation. It is an exponential type. So if you want to do this one by plotting this 5 points on a graph, it is a curve. It is very difficult to fit a curve. So we try to make it as a straight line by taking logarithm. And you see that every values of the x and y are both positive, so when you're taking logarithm is okay. For the y is you can take king. Now express log y as a linear function of x. You will find this one in your public examination. So I try this one for you. First, copy the questions. Y equal to k a to the power x. Now taking logarithm on both sides, log y. This one will get log k plus log a to the power x. And then the x can go down. Sorry, I think I make some mistakes for the logarithm. It is L N A and then x here. And arrange them, you will get log A x plus log k. You see in the solution, you can just write down this first step and then get your answer directly, just like this. So we can say that this one is the slope. And this one is the intercept. Of vertical axis. We always say this y-intercept, but actually it's not the y-axis. It is the log y-axis, but we better using it is called the vertical axis. After you make this one, you will change that the left hand side is log y is your subject, so you must calculate the log y. So according to the value 99 of y, you take logarithm is 4.6, and 622 taking logarithm is 4.1, and so on. Why we take one decimal place? It is because you are provided by a graph paper. Because log y represent the vertical axis, so you will want to find what is the accuracy of this one. You see that there is 10 subdivisions between 2 and 3. That means every subdivision is 0.1. So we may get your value is correct to the nearest 0.1. So by calculate this one, and the x is still here, so you need not to take any logarithm, so you just take 0, 2, 4, 6, and 8. After you get this one, then you plot the corresponding point. When x is equal to 0, and this is log y is 4.6, you plot here. This point 2, 4.1, this one 4, 3.7, this point 3.2, and this x 2.8. After you get this one, then you will find the y, the intercept on the vertical axis is 4.6. So you can calculate them first by the slope. Here I choose the 2 points. The first point here with the 0, 4.6, and the second point here it is the 8, 2.8. So the y in calculate slope, the y2 minus the y1 divided the x2 minus the x1 is the slope. So we write down log A is the slope, which is equal to 2.8 minus 4.6 divided by 8 minus 0. You see the slope here is negative, so you calculate is negative 0.225. If you remember in the previous exercise, if I have a log A equal to negative 0.225, then A is equal to e to the power negative 0. Then by pressing your calculator, shift log ln log, and then press negative 0.225, you will get 0.8 correct to one decimal place. And similarly, we calculate the y-intercept. Here you find that it is 4.8. So that means log k is approximately equal to 4.8. Why we say it is approximate? Because we are not calculating. We want to estimate by using graphical method. So this answer is not actual answer. So we take an approximate answer. And with log k equal to 4.6, then k is equal to e to the power 4.6, you will get approximately equal to 100. So by the result, we can let the expression become y equal to 100 times 0.8 to x, putting back k equal to 100 and a equal to 0.8. Then we want to predict the value when x equal to 12. By putting x equal to 12, you get 6.9 here. This is the first kind model. The second kind model is the power. We do not do the quick practice. This model. If you taking this model, also find that we can take the logarithm on both sides. So you must sure k is positive, and fx is greater than 0, and fx is not equal to 1. By taking logarithm on both sides, you have a product of two things on the right hand side. So you break down into two logarithm, and the n will be go down here. You will get another format. It is the capital Y, which is the log y, equal to m times log m times x. M is the slope, which is this one, the n. And the x is just this log fx, and then plus the c. C is still the log k. So we will find that we have this example. If the fx here is putting as x, that means your original y is equal to kx to the power n. Then you take logarithm, you will get log y equal to n log x plus log k. So you can draw the graph like this. You must write down the straight line equation and the log x and log y here. Now here is not similar to the previous example. The horizontal axis is changed to log x. So you want to take the data by taking both by logarithm. Now let's show an example. Two variables x and y connected by the relation kx to the power n, where k and n are constant. Here we must know that k must be positive, and x must be greater than 0, and x cannot be equal to 1. That is the problem. So you want to make the logarithm transformation by log y is a linear. So we first copy the questions, y equal to k x to the power n. So you're taking logarithm on both sides. You will get log k plus log x to the power n. And this n can go down here to get the final one is n log x plus log k. This is the things you want to do first in your expressions. Then you plot the log y against log x. It is log y against log x. So you will create another table. One is the log x, one is the log y. So you will find the expression like this. Log x is 0. Why? When taking log 1, it is 0. Log 2 is 0.7. Log 3 is 1.1, and log 4 is 1.4. Why we will take one decimal place here? Because here is approximately here, okay? And for the y, you have correct to one decimal place. So you're taking the log of 81 is 4.4. The log of 121 is equal to 4.5. And the log of the 153, you will have the 5.0 and so on. So plotting these 4 points, 1, 2, 3, 4 points here, and then using a straight line to make a straight line pass through as many points as you can and fit the data. After you get this one, then you will find the intercept on the vertical axis. It is the log k. And this one, the slope is equal to n. Okay, so we must first find out which point is better for me to calculate. We choose the following points: the first point and the last point. That is come from here. Y that is the y2 minus the y1 divided x2 minus the x1. So I get 0.6. You see the straight line is going upward, so this is a positive slope. That is n equals 0.6. N is directly calculated as 0.6, so you need not to make the transformation to get your answer of n. But the log k still have here is log k equal to a positive 4.4, so k is equal to e to the power 4.4. Then you get k equal to 80. Then you put back the k equal to 80 and the n equal to 0.6. You will get an expression like this: y equal to 80 times x to the power 0.8. when you want to predict the values of y, you want to get the answer by putting x equal to 10, you will get 318. It is the second kind model. But the second kind model is just using the fx is x. But here is another example which is not simply x. In example 2.18, the manager of a mobile phone company estimates the sales of a new model of mobile phone N. Now you are not using the y, it is the N. Just the same, it is just a variable. In a city is given by N is equal to k times bracket t plus 1 to power n. T is not, here is the like the variable x, but we do not use x here. And k and n are constant, and t is the number of months after the new model of mobile is launched. And then the data you get. If you plotting this graph to 9.4, 4, 10.1, 6, 11, and next, you get a curve. But this curve is quite difficult to draw. So we must try to make the logarithm. But when you're taking logarithm, you must sure that the expression must be a product or a quotient, a fraction form. But here is plus 2, so that means I must sure that the right hand side must be of a plus or minus something. So first I will be putting the 2 to the left hand side to make the right hand side is an expression of a product. So here the question will teach you express the n minus 2 and then take logarithm as a linear function of log t plus 1. Now I write it down for you. First, copy the questions. N equal to k t plus 1 to the power n plus 2. K and n are constant, so you want to find it out. But you have an expression on the right hand side is not a product, so you first put the 2 to the left hand side. So you get n minus 2 is equal to k times t plus 1 to the power n. And taking logarithm, the natural log on both sides, you will get it is equal to log k plus log t plus 1 to the power n. Sorry. And this n can go down, so finally I get n log t plus 1 plus log k. That means the left hand side is log bracket n minus 2 and the right hand side is in terms of log t plus 1, so it satisfies the questions. So if you have this one, that means this one is the capital Y, which is the vertical axis, and this one is the X, capital X, which is the horizontal axis. So you are want to plot the graph of log n minus 2 against the log t plus 1. So in order to get this one, you first must get the t plus 1. T plus 1 here, when t equal to 2, it is 3, and then taking logarithm, you get 1.1. You must write down this table in order to plot the graph clearly. And similarly, for the n, you minus 2 first, and then take logarithm, you will get the number here. So you want to plot the values. The first point is 1.1 bracket 2.0 is this point. 1.6, 2.1, you get this point. 1.9, 2.2 is this point. 2.2, 2.3 is this point. You must write down the logarithm of n minus 2 as your vertical axis, and the log of t plus 1 is your horizontal axis. And connect these 4 points as by a straight line, which is best fit with them. You may not pass all the points, but you want to draw a line which pass through as many as you can. Now you will get the y-intercept here. it is the log k, and the slope is just the n. So now we try. By taking logarithm, you will want to find 2 points. One point is the 1.1 and 2.0, this point, and the second point you want to find is the 1.9, this point, and which is 2.2. This point is not so fit, so we choose this 2 points. Or you can choose these 2 points, the first point and the last point, or even you can choose the third point and the fourth point. By using the values of the y2 minus y1 divided by x2 minus y1, you calculate the n, which is the slope, is equal to approximately 0.3. And the y-intercept, you see located is approximately 1.7 here. So we say it is log k is approximately 1.7. Remember, you must find out the k, so k is equal to e to the power 1.7, so you get 5 correct to 1 significance. So the whole expression you put back in here. N is equal to the 5 times t plus 1 to the power n, to the power 0.3 plus 2. So we get this expression. Then putting t equal to 12, then I will get the predicted value is 12.7933. But this is 1,000 in the unit. If you're looking at the questions, it is in thousands. But you want to get your answer correct to the least 100. So you first multiply this one with 1,000. So you get 12793.3. But correct to radius 100, it is become 12800. This is the question method for solving this one. We will discuss the example on the Zoom on next Monday.